Good afternoon. Today topic is quenching of fluorescence and its types. Here, quenching. What is the meaning of quenching? The decrease in fluorescence intensity due to the specific effect of constituents of this solution by itself. Means, what is the meaning of quenching? The definition of quenching is the fluorescence intensity of a solution decreases by itself. The decreasing of fluorescence intensity in a solution by itself is called quenching. These effects will be caused by due to various factors like concentration, pH, and temperature, viscosity, or presence of some specific chemical substances. And these quenching of fluorescence will be so many types. We will discuss in this class. Okay. First one, self quenching or concentration quenching. The self quenching or also called as concentration quenching. In these quenching at low concentrations, the linearity of a solution will be observed. At high concentrations, the same substance proportionately increase in fluorescence intensity. At low concentrations, the linearity of a solution will be observed, and at high concentration, the same substance will increase the fluorescence intensity. This is called as self quenching. And another type of fluorescence quenching is chemical quenching. In this type, quenching is due to various factors like change in pH, presence of oxygen, and heavy metals. Here, chemical quenching includes these four major various types. They are major factors. They are pH, oxygen, and heavy metals and halides. The aniline having pH 5 to 13. It gives the blue fluorescence when excited at the 290 nanometers, but at pH which is above 5 and which is below 13, the above 5 is called as cation and below 13 is called as anion. It does not exhibit the fluorescence. It does not exhibit the fluorescence at the range of pH greater than 5 to less than 13. This is about the chemical quenching of pH factor. And in oxygen, the presence of oxygen leads to quenching because the paramagnetic property. And the chemical quenching of oxygen can lead the quenching due to its paramagnetic property. By the paramagnetic property, the oxygen chemical quenching will be occurred. And halides like chlorides, bromides, iodides, electrons withdrawing groups like nitro, carboxylic groups, lead, these are show the quenching. That is decreased fluorescence intensity, which is having decreased fluorescence intensity. The quenching will be shown by the halides. And heavy metals. Heavy metals are the major factors that cause the chemical quenching. Presence of heavy metals also leads to the quenching by the collisions. These collisions will be occurred in the triplet ground state also. And when we move to the third type of quenching, that is static quenching. In this static quenching, the complex formation will be occurred. The name denotes static, means it is a complex formation For example, caffeine. It reduces the fluorescence intensity of riboflavin by complex formation. Caffeine reduces the fluorescence intensity of riboflavin by the formation of complex formation. So that's why the caffeine will reduce the fluorescence of the intensity. And the fourth type of quenching is collisional quenching. In this collisional quenching, the several factors will be present. They are halides, heavy metals, and temperature, viscosity. These are the major factors which cause the collisional quenching. And where we seen the instrumentation of this quenching, here we can see the instrumentation of quenching. This is the main instrumentation of the quenching. We already know that what are the major parts are in instrumentation means there are 5 major parts. They are source of light and filters, monochromators, sample cells, detectors, amplifiers or readout devices. In first source of light, what will be happen? The light is worked as a source which is emit a radiation and over a continuous region, then the intensity and stability will be measured. And then move to the filters. The filters, what will they do means they absorb the radiation and transmit the radiation. First they absorb the radiation and then it transmitted outside the body. And then what is the major function of monochromators? We already discussed them. So many types of monochromators are also using. They are gratings. For example, gratings is a monochromator which is used in over widely in UV spectroscopy, visible spectroscopy like that. And sample cells. Sample cells are used to measure the light intensity. And detectors. What is the use of detectors and which type of detectors used means here the photomultiplier tubes or photoelectric detectors will be used for to detect the light in that sample. And last one, readout device. In readout device we will observe the intensity of radiation and how much absorption of sample will occur and how much emission of sample will occur. We will see in that readout device and amplifier. Okay, this is about the quenching and its types and also its instrumentation.